In Module 3, we focused on behaviorism, the dominant learning theory of the early to mid-20th century. Recall that behaviorists emphasize observable behavior, and learning can be supported by manipulating the environment. While behavioral approaches are useful, they leave some gaps. Mental processes, for example, are acknowledged by behaviorists, but they're seen as being inside a black box or the learner's mind. When it became clear that behaviorism could not explain some complex learned human behaviors like language acquisition, another theory was needed to understand learning. Psychologists agreed widely on the need for theories to explain complex learning processes and began looking inside the black box in the mid-1900s. Carl Lashley suggested, quote, "The problem raised by the organization of language seems to me to be characteristic of almost all cerebral activity," from 1948. Behaviorism needed to be challenged in order to make way for cognitive understanding and for the development of personal computing. As we open up the black box of cognition in this module, our understandings, and sometimes confusion, about human learning becomes more complex. This cognitive information process model includes three types of memory: sensory memory, short-term memory, and long-term memory. From a human performance perspective, understanding this memory model is important because we want to maximize learners' ability to pay attention and to recall instruction. Sensory memory sorts and routes incoming information into the brain. It's very short, with information remaining only as long as the brain needs to transfer it to short-term memory, or, as in the case with some sensory information, quickly recognize the signals and dismiss them. Think for a moment about your own sensory memory. If you don't look at caller ID, but answer a phone, you can probably immediately identify and connect the sound of a spouse or a parent's voice. The sensory processing is almost immediate. Short-term memory is also called working memory. When the brain receives a signal that requires some thought, it is transferred from sensory to short-term memory. This process is what we mean by attention. Short-term memory has two essential qualities. First, it has limited capacity. Second, it has limited duration. In the readings for this module, you'll learn more about the limits on short-term memory. You can think of it as parallel to the clipboard on your computer. If you don't save it, it will disappear. Like a computer, you can think of short-term memory as having folders, but only two. Short-term, or working memory, collects sensory details for auditory signals and visual signals separately. This is an important detail to keep in mind as you consider instructional design. In this module, we will consider four categories to support attention: organizing attentional capacity in the learning environment, methods to focus attention, methods to support selective attention, and methods to minimize divided attention. Short-term memory has two processes: encoding and retrieval. Think about your own thinking. What do you do when you want to remember something? Our short-term memory manages its limited capacity by sorting and organizing information and moving it into long-term memory. We give ourselves cues that we can later use to retrieve it. Here's an example. To remember the Great Lakes of North America, many people use the acronym HOMES: Huron, Ontario, Michigan, Erie, and Superior. We don't have to remember the lakes all of the time. We can see the cue HOMES, and then we're able to retrieve the names that correspond with each letter. This is called a mnemonic device. The more effectively information is coded into long-term memory, the more efficient our retrieval is. In Module 5, we'll discuss schema theory. A schema, or plural schemata, are part of this efficient and effective encoding and retrieval system. Cognitive learning theory then considers how learning stimuli interact with the processes of the brain. In this unit, our focus emphasizes the way that we can design learning so that we can capitalize on the flow of information through the senses to the short-term memory. Then, how can we support learners encoding into long-term memory so that it can be retrieved and applied on demand? We also address information attrition and explore human performance strategies to reduce that loss. Long-term memory has two essential components that work together. It has a lot of capacity, though probably not limitless, and it lasts for a long time. Your readings for this module also expand on the idea of cognitive load, which is an important factor in cognitive learning theory. Clark discussed the interplay between intrinsic cognitive load, which is the mental work that is built into any learning task, and extraneous cognitive load, the cognitive demand created by the design of the learning task itself. Some methods of teaching or instructional design create too much extraneous load, and that interferes with the effectiveness of information processing. Information that is relevant or supportive of learning is called germane. The objective in learning design should not be to eliminate cognitive load entirely. Balancing the load to find the best balance for what Clark calls a productive load is optimal. The optimal cognitive load creates a just enough challenge for the learners, which increases their attention and motivation to learn, but doesn't go so far as to create too much extraneous load, causing frustration or overwhelming them. The information in Module 4 provides a really important building block in this course as we move along the continuum that we introduced during the last two modules, going from behaviorism toward a constructivist way of understanding adult learning, how we can design human performance approaches and capitalize on the science of cognition. As you work through the readings and discussions in this unit, consider the ways that you can help learners increase attention, organize sensory input, practice that input for more efficient long-term memory storage and ease of retrieval. Your toolbox of techniques for learning design will grow in diversity and effectiveness as you apply these fundamental principles of memory to meet human performance objectives.